Let's talk about congruent figures. So we want to say these are congruent figures. Mathematically, we really can't unless we know all of this information about the two figures. We need to know that each angle in this figure has a corresponding congruent angle in this figure. And we need all the sides to have a congruent corresponding side. AN has to be congruent to HK and so on. Then we can say that the two figures are congruent. And this is also true for a seven-sided figure. We just have to have corresponding for all 7 angles and all 7 sides. Same thing for a 4-sided figure, and this is true for all figures, but there's something special about triangles. Now, if I got rid of these angles and we only knew the 3 sides, that is enough to say that these two triangles are congruent. We don't need to know the angles. But if this were a quadrilateral and we got rid of the angles, we can't say for sure that these are equal just because the sides are equal. Here's a counter example. Notice how this is the same length as 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 this, but these are not the same figure. They have different angles. So we need these angles to show us that all those different sides are coming together in the same way. Going back to a triangle, this is sufficient, just having the 3 sides. There's no way these angles could be anything different. There's no way we can change the shape. We call this SSS, or side, side, side. If we have corresponding sides of the two triangles, we know the two triangles are congruent. We can also do that with side, angle, side. So if we know that this angle corresponds to this angle and the two sides on either side of that angle are congruent, we know these two triangles are congruent. And that works for this side angle side and also this side angle side. If we have this information, it's enough that we know the two triangles are congruent. Same thing for angle, angle, side. If we have this arrangement, angle, angle, and a side, and we know those are congruent, that is enough to show that these two triangles are congruent. And angle, side angle works as well. If we have 2 angles and the side in between them, we know that these two triangles are going to be congruent. Now here's some examples of stuff that won't work. AAA, or angle, 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 won't work. And here's a counterexample why. This angle is the same as D, B is the same as E, and C is the same as F. You can tell the two figures are not the same. So we can't use AAA to show that they're congruent. Another one that won't work is SSA. It's not enough to show the two triangles are congruent. And here's a counterexample right here. We have an angle that matches, we have a side that matches, and we have another side that matches. But notice these two triangles are not the same. But there is a special case of SSA that does work, and that's called HL. If we know that the angle is a right angle and we have a hypotenuse and a leg of the triangle, we now know these two triangles are congruent. So this is the hypotenuse here, and this is a leg, or this is a leg. So as long as we have one of these 2 legs and a hypotenuse, it's fine that we have the angle not in between the sides, and we call that HL. In summary, any figure that has more than 3 sides, you need to have all the information to know they're congruent, or at least enough information to calculate all of them. But in triangles, if you do have any of these 5 combinations of 3 congruent corresponding parts, that is enough information to conclude that the two figures are congruent.